The first question here has to do with finding the mean of this rent data. So to find the mean, we simply need to find the sum of the values and divide by the number of values. So in this case, when we add up these values here, the sum we obtain is 3060. Hence we have 9 of them, we divide by 9, and that gives us 340. So the mean is 340. For the median, we first need to sort the values from smallest to largest. So we go here from 280, 300, 375, and then 420. And if we number this, we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So since there are 9 observations, the middle value is 350. So the median is 350. The mode is the most frequently occurring value. So the most frequently occurring value here is 300. So we have a mode of 300. To find the 76th percentile, we first need to use the percentile locator to locate the position of the 76th percentile. So we have 9 values, so n is 9 plus 1. And then the percentile we're looking for is the 76th percentile, so we divide that by 100. When we evaluate this, we get 7.6, which means the 76th percentile is a value between the 7th and the 8th observation. Now, the 7th observation here is 360, and the 8th, after sorting the values, is 375 over here. So the distance between them obviously is going to be 360 subtracted from 375, which will give us 15. That's the distance between them. The 76th percentile is found by taking the 7th value, which is 360, and then because we have a 0.6 here, 7.6, we're going to add 60% of the distance between the 7th and the 8th observation, which you obtain here to be 15. We're going to add that to 360, and that will give us 369. So 369 is the 76th percentile. And what does this mean with respect to the data? Now, these are rent values. So the amount of rent was what was given to us at the beginning. So we can say that 76% of the rent values are less than $369. That's pretty much how to explain that. Now in question 2 here, we need the mean, median, mode, and range. So we're just going to find the mean the same way we just found it a moment ago. The mean is going to be found by taking the sum of the values. When we add up these values here, we will get a total of 55. And when we divide that by 10, we have a mean of 5.5. For the median, again, we first need to sort these values from smallest to largest. So if we're sorting this with the smallest value here is -10, followed by -4, 19, and then 20. And I'm just going to quickly number this. So we have 10 of these values. Now the median is going to be the middle value, but because we have even number of values here, the median is going to be between the 5th and the 6th observation. So we just need to average those two numbers. So we take 3 plus 5 divided by 2, and that will give us 8 over 2, which is 4. So the median is 4. For the mode, we don't have any value here repeating more than once. So in this case, we have no mode, or there is none. Next, we need to find the standard deviation of these values. We already have a table created for us here. We just need to complete it very quickly. Now, we know the mean here, sample mean x bar, is 5.5. So first, we need to find the deviations from the mean by subtracting 5.5 from every single value here. So if we do 20 minus 5.5, that will give us 14.5 here. And when we add up these deviations from the mean, the sum here must always be 0. The sum of deviations from the mean must be 0. Next, we need to square these distances from the mean. And that adds up to 890.5. So to find this standard deviation, we just need to take the square root of the sum of square deviations and divide by n minus 1. And that will be square root of 890.5 divided by 9. N is 10, so n minus 1 is 9, which will be the square root of 98.94444 repeating. That will be approximately equal to 9.95. So the standard deviation to 2 decimal places is 9.95. Next, we want to find the 35th percentile. To find the 35th percentile, we first need the locator of the 35th percentile. So again, we're going to employ the locator formula here. N in this case is 10. So we're going to have 10 plus 1 times P is 35 over 100. And that will evaluate to 3.85. So that is the position of the 35th percentile. Now 3.85 is between 3 and 4. That is between the third and the fourth observation. So between -3 and 2. We'll find the 35th percentile by starting with -3 plus, then we take the decimal part here, the 0.85. That's 85% of the distance between 2 and -3. So that's 2 minus -3. And that will give us -3 plus 0.85. And this will be 5. And that will evaluate to 1.25. So the 35th percentile is 1.25. And how do we explain that? So again, we say 35% of the values will be less. So 35% of the net weight gains are less than 1.25 pounds. For the third question, we're looking at weighted mean here. We're trying to use the formula for weighted mean, which is sum of the weights times the values divided by sum of the weights. Now here we want the weighted mean price, cost per liter. So price is going to be our X and the quantity of gas will be the weight. To find the weight times X, that's the total price for each quantity purchased, we multiply the weight by each of the prices. So for the first one, we get 39.9, 44.52. So we need a total at the last row here, and then we need a total for the first row. So if we find the sum of the weights here, we will obtain 220, and we find the sum of the total prices here, we will have 251. The weighted mean is now obtained by taking 251 and dividing that by the 220. So that is total price divided by total quantity, and that will give us $1.14. For this next question, we are going to be applying the empirical rule. The empirical rule says that we have approximately 68% of all our data within 1 standard deviation of the mean, 95% within 2 standard deviation, and approximately 99.7% within 3 standard deviations of the mean. So here we have a mean of 55 and a standard deviation of 6. So if we look at this here, we will say we have a mean at the center of the distribution, which is at 55. 1 standard deviation above the mean there will be 55 plus 6, which will give us 61. 2 standard deviations above the mean is going to be 67 here, that's 61 plus 6, and 3 standard deviations above the mean here will be 73. That's 3 standard deviations above the mean. Now below the mean, 1 standard deviation below the mean will give us a value of 49. 2 standard deviation below the mean will be a 43, and 3 standard deviations below the mean will be a 37 here. So the rule says that we have about 68% here within 1 standard deviation of the mean, and we have approximately 95% within 2 standard deviations of the mean, and we have approximately 99.7% within 3 standard deviations of the mean. So the first question here asks approximately 99.7% of the cartons will be sold within what range of values? So apparently 99% of it will be sold here. So that will be between 37 and 73. Now for the second question, says approximately what are the chances that supermarket will sell more than 61? So more than 61 is asking for everything to the right of this 61 here. More than means to the right. Simply look at the distribution we have. We have 61 here, and because of symmetry, within one standard deviation, we have 49 to 61, which comprises of 68% of all the data values. So, which means we will have 34% here and 34% there. Okay, so, but because 50% of the data will be greater than the mean, then it means we have 50% in the entirety of the right part of the distribution here. And on this side here, we will have 50% minus 34%. Okay, and that will be 16%. So 16% will sell more than 61 cartons per day. Now, the next question says, approximately what are the chances that a supermarket will sell between 49 and 67? So again, if we look at that curve, we have 49 here. That was within one standard deviation of the mean. We had 61 here, and then we have 67 here. So the question requires us to find the area contained between 49 and 67. So according to the rule, again, we know that 34% of the values will be here. From 55 to 67 is going to be half of 95%. So that will be 95% over 2, which will be 47.5% contained in there. So if we want the total area here, we're looking at 34% plus 47.5%. And that will give us 81.5%. In the original question, we have a histogram. But then this is another variation of the question which does not have a histogram, which basically challenges your understanding of the frequency polygon and the ogive. Now, like I said, the frequency polygon is basically just a histogram that is replaced with midpoints of the distribution. So for example, if you look at this frequency polygon, I can actually generate the original histogram that was there. That will be the first interval, and then I can go on and obtain the second interval like that. Okay, I can just use the midpoint there to obtain the histogram of the data. So that is the simple histogram of the data, and 17.5 is the midpoint. So it means we're just going to have a 15 here, and then this one is going to be a 20, and then we're going to have a 25, we're going to have a 30, we're going to have a 35, and then a 40, we're going to have a 45, and then a 50 up there. So I can either use that histogram, or I can also use the ogive to answer the given questions. So let's see how that goes. So the first question asks, how many volunteers participated at the event? To find the number of volunteers that participated at the event, we just simply need to add the total frequencies here for each of these observations. So if we add those total frequency, we will obtain 80, and that will be the number of participants at the event. The next question says, how many class intervals are used? We just need to count the number of intervals or the number of bars here. And if we count that, we'll see that 7 bars or 7 class intervals were used. The next question is asking us that based on the 2K rule, is the number of classes appropriate? The number of classes based on the 2K rule, the 2K rule says that 2 to the power of k has to be greater than n. We're looking for the smallest k such that 2 to the power of k is greater than n. N in this case is 80. So we're looking for the smallest k so that 2 to the power of k is greater than 80. So if we take 2 to the power of 6, for example, that's going to be 64, which is not greater than 80. 2 to the power of 7 is 128, which is greater than 80. So the smallest k that will give us a value greater than 80 is 7. And guess what? 7 class intervals were used. So based on the 2 to the power of k rule, the number of classes is appropriate, and that is 7. So next question is asking if the distribution is positively skewed, negatively skewed, or symmetric. So we know that a positively skewed distribution is tailed to the right, like that. So that's a positively skewed distribution. And then a negatively skewed distribution has the tail extending to the left like that. That's a negatively skewed distribution. And a symmetric distribution, of course, when you split it in half, it basically has a mirror image of itself. So if you look at the distribution here, it is obvious that the tail extends to the right. So it tails to the right, tails off to the right. So we're looking at a positively skewed distribution there. So the next question asks for the width of each class interval. The class intervals are the 15 to 20, or what we can see here. Those are the intervals of the classes. So 15 to 20 obviously will give us a value of 5 for the width of the interval. What percent of the volunteers is 35 years or older? Okay, so there are different ways of answering that question. We can either use the cumulative ogive, or we can just go here and say, okay, we have 35 here. We're looking at these numbers. So that's 10 plus 7 plus 3. Those are values. That's the frequency of values that are greater than 35. So if we add those three together, we will obtain 20. So, but the question is not asking for the number of volunteers this time. It's asking for percent. So that will be 20 over 80, which is going to give us 25%. The next question asks for the midpoint for volunteers under 20. So if we go here, volunteers under 20, this is the interval for volunteers under 20. The midpoint of the interval is actually 17.5, as we can see there. Or we can simply take 15 plus 20 divided by 2, and that will give us 17.5. What is the cumulative relative percent for volunteers under 30 years old? The question is essentially asking us for the percent of volunteers under 30 years old. So cumulative just means adding up to 30. So cumulative relative percent for volunteers under 30 years old is percent of volunteers under 30 years old. So if you look here, we can just simply find that value there, and it's given to us here. It's 58.75%. That is the answer to that question. Alternatively, if we're using the frequency polygon, we can add these values up. We're looking for values less than 30. Okay, add those up. That will give us 47, and we can divide that by 80, and we will get the same result. What is the median class interval? So the median class interval is not just the class interval in the middle. It is actually the class interval that contains the middle value. The class interval that contains the middle value, we have 80 values here. The middle value will be between 40 and 41. So by the time we add 4 and 25, we will get 29. By the time we add 18 to that, we will get 47. Okay, so it means the two middle values, the 40th and the 41st observations, will be between 25 and 30. So the median will be in here, the 40th and the 41st observations. So in that case, the median class interval will be 25 to under 30. And of course, the model class interval is the class interval with the highest frequency. So we go up here and look for the class interval with the highest frequency. And over here, it is this tallest bar over here. So it's that class that goes from 20 to under 25. That will be the class interval with the highest frequency, the model class. In this last question, we want to use this table and output to answer the given question. So we're looking at household size and the amount of paper discarded weekly. The first question here is asking if we want to estimate the amount of paper discarded, which variable is the dependent variable, which is the independent variable. Now we will expect the amount of paper discarded to depend on the household size. So y is the dependent variable and x is the independent variable. So question is asking for the dependent variable. So the dependent variable is the amount of paper discarded, and the independent variable will be the household size. So we have this output, this regression output for the problem. First question here asks us to determine the regression equation, which is the linear regression equation y hat equals b0 plus b1x. That is the regression equation. And from the output, we know that where we have coefficients here, the intercept is our b0 and the slope is our b1. So the intercept there is 0.6885 plus the slope, which is 0.7992x. So that's the regression equation. Next question wants us to find the value of the correlation coefficient R, and it's asked us to comment on the strength and direction of that correlation. Now that takes us to the top part of the output here. Now in this output, R is given to us, that is R. Now sometimes it's not given to us, so we have to find it. And it's easy to find because this is R squared here. To find R, we can just take the square root of R squared, and that will give us R. However, when you take the square root of a positive number, the result could be a plus or minus value. So we need to know that if R is not given, we could get a plus or minus value for R when we take the square root of R squared. So how do we know the actual sign? Should we go for R equals negative square root of R squared, or should we go for R equals positive square root of R squared? And the answer basically is this. We look for the sign of the slope. If the sign of the slope is negative, then R will be a negative value. And if the sign of the slope is positive, R will be a positive value. So that's pretty much how we find R if R is not given to us. But in this case, R squared is given to us. R is given to us. The question is asking for R, the correlation coefficient. So it is 0.9018. And of course, we need to state the strength and the direction of that relationship. So here, this value here is close to 1. Okay, so we say we have a strong correlation, and the direction talks in terms of positive or negative. And we've just established that it is a positive relationship. So the relationship is positive and it is strong. The next question wants us to find the coefficient of determination, which is R squared. Now, if we have R, we can either square R or we can just look up R squared from the table if we have R squared in the table. So in this case, we have R squared, it is 0.8133. So that is just our R squared. That is our coefficient of determination. And what does it tell us? We need to be able to explain that. So we say that 81.33% of the variation in Y, okay? But we have to state what Y is. Y in this case is the amount of paper discarded. Okay, is explained or can be explained by the variation in the household size, which is X. So basically, R squared or coefficient of determination is the percent of variation in Y that is explained by the variation in X. And that's basically telling us that the remainder is not explained. So if 81.33% is explained, we can subtract that from 1. That will give us 0.1867. So about 18.67% is unexplained. Interpret the value of the slope as it relates to this problem. So we saw the slope earlier on. The slope is 0.7992. Now, the slope is basically the amount of change in y per unit increase in x. We have to interpret that as it relates to the problem. So in that case, we will say that for every additional household member, so the amount of paper discarded, which is y, okay, that will increase because the slope is positive by 0.7992 kilograms is in kilogram on average. So for every additional household member, or for every unit increase in household size, or if household size increases by 1, paper discarded increases by this amount on average. The last question here wants us to estimate the size of paper discarded when the household size is 7. So that is when x is 7, what is an estimate of paper discarded? So we do y hat here equals 0.6885 plus 0.7992x. And x in this case is 7. So we just plug that in there, and that gives us about 6.28 kilogram amount of paper discarded. And that's it. Thanks for watching.